NASA's Orion spacecraft splashed down in the Pacific Ocean December 11th, successfully completing the Artemis I flight test. Since then, engineers have been reviewing terabytes of data to confirm initial observations from the mission, which began with a successful liftoff of NASA's Space Launch System rocket November 16th from Launch Pad 39B at NASA's Kennedy Space Center in Florida. During its 25.5-day mission, Orion traveled a total of 1.4 million miles during the journey out beyond the moon and back to Earth to thoroughly test systems in a deep space environment before missions with astronauts. Here to talk with us about the status of the post-flight assessments and preparations for the Artemis II flight test are Jim Free, Associate Administrator for the Exploration Systems Development Mission Directorate, John Honeycutt, Manager for the SLS program, Howard Hugh, Manager for the Orion program, and Sean Quinn, who is the new Program Manager for the Exploration Ground Systems program following Mike Bolger's retirement. Each of our speakers will share a few opening remarks, and then we will take your questions. Reporters on the line can enter *1 on your phone to be entered into the question queue at any time. And Jim, we'll turn it over to you now.
All right, thanks, Catherine, and good afternoon or good morning, depending where you're at. Let's see, Catherine, I guess set the scope of the call pretty well. We want to talk a little bit about some Artemis I stuff. We'll talk Artemis II, and then certainly answer questions that you have across that scope. And still so happy about the successful flight that we had of Artemis I, and as we continue to, look at the data, we're certainly learning more, and you'll hear some about that today. But, that was a flight test for us really to prove out our systems in that real environment, and even push it beyond, push the vehicle beyond where we had originally intended with our ability to add flight tests, some of which you heard about in previous calls. We did accomplish, I think, that the objectives and very well. We're still pouring through the data. There's a ton of data that was recorded and transmitted down and recorded on board that we have off the vehicle now, and I'm sure Howard will talk some more about that from an Orion perspective. We're looking at the detailed analysis across the entire vehicle, every part of it, every subsystem. We're also looking at collecting our lessons learned. Our lessons learned process is very structured and formal, that we're going through right now. Each of the teams is represented across everything. Our international partners, actually Howard and I are in Germany right now with the folks working the European service module. They're part of it. Our communications people are part of it. Every angle that you can imagine, we're making sure we're capturing those lessons learned. The preps for Artemis II continue to move forward, and of course, this is a flight test, again, with humans on board. And I preached today to the team here, and I've been saying that this is the time for our vigilance to continue. We have heartbeats on this mission that we need to make sure that everything we're doing, we understand the risks that we're taking, we understand the performance of this vehicle moving forward. As we look at Artemis II, we'll continue to look deeper into the analysis that we're seeing of things from Artemis I, the mobile launcher that Sean will talk about. Took a little bit more damage than we had originally thought. We're looking at a couple of anomalies that we saw during the mission on Orion that Howard's going to talk about. We'll continue to look for those areas to really make sure that our confidence continues to grow every day as we move towards Artemis II. I do want to take a moment. We haven't had a call. I haven't been on a call since the recovery. I do want to thank the recovery team. Melissa Jones led that for us. Our Navy partners just did a tremendous job at bringing the vehicle home. We're looking forward to that crew flying on Artemis II. And with that, let me start and turn it over, I guess, first to John Honeycutt.
Hey, Jim. Hey, folks, it's good to be with you today. We continue to see outstanding performance from SLS, and it's done an outstanding job and met all our expectations, and in fact, it exceeded most of them. As Jim mentioned, we've got a lot of data to pour through. We've made our way through a great portion of that. I'll tell you the correlation between the predicted performance and the actual performance was excellent. When I look ahead to Artemis II, our post-flight data analysis continues to show SLS is ready to support crewed Artemis missions. Our NASA SLS teams and our contractor partners are more focused than ever on building and testing and assembling hardware for the first crewed flights and the next configuration of the rocket, Block 1B. A little more detail on Artemis II. We've got a lot of focus at the Michoud Assembly Facility with the core stage. The teams down there are preparing for the engine section join to the rest of the 4/5 of the rocket. That's the last major element of the core stage to be joined, and then the 4 RS-25 engines will be integrated into the engine section. As a matter of fact, we have, I think we've got 2 of those engines already unboxed and staged for installation as we speak. And then we're continuing out in the future relative to RS-25 engines. We've got a production restart acceptance test series. It's ongoing at the Stennis Space Center, and we've got an engine test scheduled for later this week. I will say that it was great performance by the enterprise for Artemis I. I know our team is energized from the launch of Artemis I, and we're in a good position to support powered flights for Artemis II and beyond. I think I'm over to you, Howard.
Thanks, John. Yeah, good morning or good afternoon, depending where you are. Let's see. It was an amazing flight. Orion exceeded all performance expectations and certainly was very pleased with the mission. The team did an incredible job of obviously getting to launch and executing the mission and returning the spacecraft. And then, of course, as you know, Orion's a collaboration across the globe and with our industry partners. I first want to thank ESA and Airbus for incredible European service module and their ability to perform excellent in terms of their their element of the spacecraft. And of course, Lockheed Martin, who is responsible for our crew module, and their subcontractors as well, building the crew module, the CMA, and the LAS. So really great performance across the board for the spacecraft. And I do want to echo what Jim said. I want to thank Sean and the EGS team for a great recovery effort in returning the spacecraft over the Christmas holiday and getting it back as we need it to start getting the avionics out of the Artemis I spacecraft to go to Artemis II spacecraft, and I'll talk about that in a little bit. Let's see. We did have a record-breaking mission in terms of where Orion went to the moon. We got as close as 80 miles to the surface of the moon, and we traveled further than any human spacecraft has gone before, 270,000 miles from Earth. So that was quite an accomplishment. We got pictures that I think inspired the world and certainly brought big smiles to the team in what we were able to see from that mission. We also accomplished what our number one objective was, which is returning the crew module back to Earth safely from 24,500 miles per hour to landing about 16 miles per hour when it touched down. And we were able to land within 2.4 miles of our target. Our requirement was 6.2 miles, so really great performance as we were able to return back from the moon. Along those other objectives that we had 161 overall flight test objectives that we were able to accomplish and demonstrate throughout the 25.5-day mission. In fact, we added 21. I think we talked about this during the mission. We were able to add 21 new objectives real time as we were getting better performance than we expected, and we pushed the envelope of what we need to do as we try for future missions that are more complex, and that would give us more data to operate in those mission parameters and those missions ahead. And of course, we had 375 power devices that worked very well on all separation events that I don't think we talked about before. So overall, really great performance with the spacecraft. Now we have a load of data, 155 gigabytes of data to go through. we're in our initial assessment of all that data, corroborating not only what we saw in the images and the videos, but also all the engineering data we collected from our sensors, and looking at it across the board and making sure that we correlate that data and it draws a complete picture for us. Let's see, a couple items of interest that I think I'll bring up today. One is the latching current limiter that we heard about or you might have heard about during the flight. There was 24 uncommanded LCL events, and we were obviously able to recover them through flight operations commands, and no impacts to spacecraft performance or power generation. The ESA and Airbus team is doing a terrific job of initiating and executing that investigation. Right now, they are working on getting ready for a test at the end of this month and getting a setup that is representative of not only the hardware, but also the configuration, and seeing if there is electromagnetic compatibility kind of issues that are driving noise into the system that could potentially open up these LCLs uncommanded. So this will be very interesting at the end of the month as they go through a couple weeks of tests to show if we can find root cause associated with this event. Another event of interest is during when we returned the crew module and inspected the heat shield, we observed there were more variations across the heat shield than we expected. Some of the expected char material that we would expect coming back home ablated away differently than what our computer models and what our ground testing predicted. So we had more liberation of the charred material during reentry before we landed than we had expected. So right now, we're working very hard on investigating, taking data that we collected from the images and the videos from the reentry, correlating that with the heat shield sensors that we had on board, and then also, of course, taking a look at our computer models and looking at how we can understand that phenomenon we experience on reentry. We do have a dedicated investigation going on with detailed analysis. We have extracted some samples from the heat shield, which we're doing X-rays against. We are also understanding how much virgin or remaining abcoat was remaining on the heat shield, and that was significant, still remaining. So that was really good. But overall, there's a lot of work to be done in this investigation going forward. We are just starting that effort because we've just gotten together all those pieces of information, those samples, the videos, the images, and the data from the spacecraft itself, and correlated them together. And now we're assessing that data and moving forward with that assessment. So with that, I will talk about Artemis II. We're making great progress on Artemis II as well. Artemis II, we're gearing up to fly the first crew on Orion and on top of SLS. I think many of you may be wondering, we did, like I said, thank EGS for their excellent recovery and return of the spacecraft. We were able to extract the Artemis I avionics components very quickly, refurbish them, and they're all installed actually ahead of plan by several days. So that was really good news. That continued our flow of Artemis II crew module completion. And we're also doing a lot of work now on the testing of both the service module and the crew module. Currently, we're finishing up the integrated service module acoustic test. It'll be finished tomorrow, and then we'll be doing final touches with the service module in prep for stacking with the crew module. The crew module is finishing up both subsystem tests and communication GNC, and they've got a couple other functional tests remaining, and then we will go through a crew module thermal cycle test. It's one of the remaining tests on the crew module before we do the stacking as well. Certainly, as many of you know, we have new hardware that did not fly on Artemis I. We have displays, we have the life support system for the crew, we have thermal control inside the crew cabin that manages temperature, and of course, we have the translational hand controls and rotational hand controllers that the crew would need to use if they had to take manual control of the spacecraft. all those new hardware have been installed. The testing ahead for this first-time install hardware is still ahead of us as an integrated system. And of course, we've got the final checkouts of the crew and service module stacked together and that final set of integrated tests before we roll out of the ONC for Artemis II flight. Let's see, you know, Jim mentioned it and others have. We are doing due diligence in terms of looking through every piece of data across the board and images and videos that we extracted from the spacecraft and from other assets from Artemis I. And we are applying that to ensure that we can fly the crew safely on Artemis II. And we're making great progress on the Orion side. So I'm very excited going forward to complete this assessment, capture all the lessons learned, implement lessons learned for Artemis II, and see the crew fly on Artemis II. So thank you.
All right. Thank you very much, Howard. This is Sean Quinn. I'm the relatively new EGS program manager. I also have my deputy here today, Jeremy Parsons, in case I need help answering any questions. I will say that at KSC, we're still very much savoring the successful launch of Artemis I. I will always remember picking up the count at T-minus 10 minutes and proceeding all the way down to T0 without a single violation of our launch commit criteria. The vehicle clearing the tower was a magnificent sight to see as it followed its precise trajectory into space. It was really a magnificent day for all of us. Overall, we're very pleased with the performance of the ground systems throughout the Artemis I flow, including stacking, launch operations, and recovery. Critical umbilicals on the ML tower worked exactly as designed. Our new command and control system worked like a champ, as well as the rest of the EGS ground systems. Since Orion returned to the Kennedy Space Center, teams have been working to deservice the spacecraft, removing ammonia and fuel. Several payloads have been removed, including the 3 mannequins, as well as several biology experiments. One thing to remember is that Artemis I was as much of a test for the ground as it was for SLS and Orion. We are applying the lessons learned from the first flight as we prepare for Artemis II. Now, I'll tell you, we did sustain a bit more damage than anticipated to the ML, but we are on track making repairs, so we'll be ready for Artemis II. You got to remember, SLS was the largest rocket ever launched from SLS. It's very, very powerful. Since the Artemis I launch, we have removed all the SRB residue from the mobile launcher. We removed blast shields around the flame hole and have already begun to repair some of the cabinets and control panels that were damaged. Replacement of the pneumatic lines are in work. Our contractors are on site working every day to get the pneumatic lines replaced. You may have heard about the ML elevators that were damaged. One elevator has already been returned to operation, and we are considering additional hardening requirements to protect against future damage. We have several modifications and enhancements previously planned to support Artemis II that are well underway. On the mobile launcher, we moved it back to the park site a few weeks ago, and we are making modifications to support the astronaut crews that will fly on Artemis II, including emergency life safety systems. These capabilities were not required for the launch of the uncrewed Artemis I flight. We are due to return the mobile launcher to the launch pad this summer to do additional testing and work on integration of the emergency egress system with the systems at the pad. In the Launch Control Center, we are updating our launch countdown timelines to include crew donning of the spacesuits, making the trip to the launch pad, getting into the spacecraft, and atop the launch vehicle. We're making updates to our ground software for Artemis II that will include additional automation, and these are largely based on lessons learned from Artemis I, as well as adding additional capabilities to support Orion's life support systems. In the vehicle assembly building, we are replacing the portable purge units used for Artemis I. These are shuttle-era components that are long past their useful life. We're replacing it with new facilitized environmental control systems that will support the crewed missions, which will provide air supply, thermal control, and pressurization to the launch vehicle and spacecraft during stacking operations in High Bay 3. Out at the pad, our new 1.4 million gallon liquid hydrogen tank is essentially the construction is complete. The increased volume of the liquid hydrogen on site will decrease the time between future launch attempts. We will be testing the new hydrogen sphere later this year. With our crawler transporters, we're replacing some of the shoes on the crawler transporter trucks. Later this year, we'll of course use the crawler transporter to take the mobile launcher back out to Launch Complex 39B for testing. You may have heard about our crew module test article training device. Our landing and recovery team, along with the Department of Defense, completed a rigorous round of testing on their new mock-up of the Orion spacecraft last month right here at KSC's Turn Basin. They will use this test article to train Navy, NASA, and other DoD personnel to retrieve the astronauts from the Pacific Ocean after splashing down from the Artemis moon missions. So far, our preparation is looking great for the upcoming crewed flight, and with that, I'll pass it back to, I believe, Jim.
Hey, this is Catherine. We'll now take questions from reporters on the line. Those on the phone can press *1 to be entered into the queue at any time, and press *2 if you'd like to be removed from the queue. Your lines are on mute now, and the operator will open and close your mic when we come to your question. And please keep it to one question so that we can get to as many of your fellow reporters on the line as possible. First, we'll go to Gina Sunseri with ABC News.
Given the early installation of the electronics, do you think you can move crew to Artemis II launch date up at all?
I mean, I'll start and I'll let Howard add in. You know, now there's a pretty defined schedule that we had in place as we waited for those, and I think while we had the processing time in there, we were optimistic, and that's my word, not Howard's, on when we could get those back and put them in. That still put us in that late November of 24 timeline. Of course, then we factor in the rest of the flow once the Orion is turned over to the ground processing folks. So I don't think that helps us move it in. We'll certainly look for ways that we can build margin in our schedule. That's how we look at it. But getting those out, retested and reinstalled was the best case for us, and that really doesn't allow us to move it up at all. Howard?
Yeah, Jim, I think we were very aggressive in terms of, you know, making sure we got the vehicle back. When I say aggressive, making sure we took every opportunity we can in refurbishment and also installation, and it went just as. And so to me, it's earlier than we had planned. So to us, that was really good news and excellent job by the team. But with that, I agree with what you said, Jim.
Thank you. Our next question is from Marcia Dunn of the Associated Press.
Yes, hello. For Howard, how much more charred material came off the heat shield than anticipated? How close to the safety limit was it, if at all? And for Sean, what was the extra unanticipated damage to the mobile launcher, if we could have some details? Thanks.
Yeah, Sean, maybe I'll go first to answer. Hey, Marcia, I would say we don't know yet how much, so that's the analysis we need to do. We're looking at each block and doing our measurements against it. And then we, like I said earlier, we had a significant amount of margin left over, what we call virgin avcoat. And so to me, from when you say the limits, I don't believe we reached any limits in terms of from a margin perspective. Certainly took more margin, took more of the avcoat off than we had expected. But again, that's something that we'll look through from a data perspective and gather all the quantitative data as we can, the sensors and from what we saw on the videos and images.
Yeah, and this is Sean Quinn. And as far as the damage to the mobile launcher, first of all, we were very pleased with how critical systems performed, such as the umbilical arms. There are a few things that did receive more damage than we expected, including some of our pneumatic lines. After launch, we lost our gaseous nitrogen supply, which delayed the flow of water that would have rinsed off some of the SRB residue early. And because of that, we had some of our pneumatic lines get corroded, and we're right in the middle of replacing those as well. We had some of the blast plates around the flame hole were also received a little bit more heat damage than anticipated, and those are already off and being replaced as we speak. And as you heard, the we lost our mobile launcher tower elevators, and the first one's already been repaired, and we are considering additional hardening for the second one for the next flight.
Thank you. Our next question is from Joey Roulette of Reuters.
Thanks. Question for Sean. For that mobile launch tower enhancements and additional hardening, as you said, how long do you expect that to take, and how much could it cost? And then one question for Howard. What are some potential solutions, I guess, you guys are currently seeing for the Orion heat shield? I know it's early to pick any kind of single option, but I mean, if there was more charring and liberations than expected, could you theoretically, I guess, add more protective material to that, or would it require some redesign, or just what are you guys kind of thinking at this point? Thanks.
Yeah, so this is Sean Quinn again, and I'll take the ML question. So as far as how long the hardening is going to take, we're still working with our contractors on it, and we don't have a firm cost. But I will tell you that some of the damage, we did have a budget wedge that we planned in with our program to take care of the unknowns. Whenever you fly something new for the first time, you're going to learn something, and this is the case with Artemis I as well.
Yeah, and let me answer for the question you had on solutions. I would say that, we want to find root cause for the phenomenon, or better understand the phenomenon we saw on the return. And to me, I don't think I would jump to any solutions yet. It may be just part of what the heat shield is and what we would expect as we return from the moon. And so it's very early for us to think about any potential solutions to address any additional char loss or liberation. But I would say that that's still early in our assessment, and we're still early in our assessment, and we need to go work through the data, and that data will inform us about how we want to go forward with the future missions ahead.
Thank you. Our next question is from Bill Harwood of CBS News.
Thank you very much. And apologies, Catherine, two questions, but one's a short one. Just for Howard, can you just tell us what char loss even means? In other words, what's coming off versus, how much you expected to come off, and is this any kind of a safety or even a potential safety of flight issue? And I have a question for Jim Free. Jim, you told us months before launch, before the first fueling attempt anyway, that the lawyers were going over the bar chart countdown timeline and things like that to see what you could release. I don't ever recall seeing anything like that. I'm just wondering what's being done to free up more technical details for us going into Artemis II. The ML is a good example. We saw a couple of pictures of elevator doors, but we've never been allowed to go take any good pictures or anything like that, and never really gotten any detailed updates beyond what we've heard today. So just a general question along those lines. Thanks.
Yeah, hey, Jim, I'll go first. Hey, Bill. So you can imagine, we have a ablative heat shield, so we expect the material to ablate. And so part of that heating, the 5,000 degrees Fahrenheit that you would encounter on a reentry up to that temperature, you're going to see a charring of that material, kind of what you do when you barbecue or something like that. And so that's expected to happen. That was planned. Now, what normally happens as you get charring, you'll have losses through a chemical reaction. Some of it we're seeing as larger, like more of a little pieces that are coming off versus being ablated. And I think that's one of the things that was a little bit unexpected as we return back from the moon. And that's where we're going through the data and looking at what we saw visually and what our sensors told us relative to temperatures and the profile of those temperatures that we experienced on reentry.
Yeah, and Bill, thanks for the question, and thanks for keeping us honest on that. I think what you hopefully saw in Artemis I was we tried to be more open as we went through the process, even through the the commentary. I'm not saying we're perfect. Even through the commentary during the countdown, the imagery release during the mission, we tried to do better at that. I will tell you that the lessons learned process that I mentioned the communications folks and Catherine Hamilton and Rachel Kraft are excellent leaders for us in that. The part of the lessons learned will include what can we do better on timeline, on technical detail release. We're looking at a very structured process for imagery release for Artemis II that we're working closely with Vanessa Weish at the Johnson Space Center. Vanessa is the center director there, to have a plan for imagery release both before and during and after the mission. So I want to, just like I'm counting on Howard and all the teams in the lessons learned process to come forward with that as part of our structured process that will culminate, I'd say, September, October of this year when we outbrief the agency on our lessons learned, and that should be part of it. So we'll continue to grow, to continue to share as much information and grow how we do that through those two processes that I mentioned.
Thank you. Our next question will be from Jeff Faust of Space News.
Good afternoon. Question for Howard on this latching current limiter issue that you had. If the testing that's coming up doesn't find a specific root cause, would you just fly that as is on Artemis II and deal with it as it comes up during the course of the mission, or would you look to make other changes to try and resolve the problem? Thanks.
Yeah, thanks. Good question on that. So if we don't find root cause, obviously we did it during the mission where we did the commanding to close the LCLs. Now, of course, we have crew on board as well, so they are able to do that through the displays. The other option that we've talked about and that we would explore would be a software implementation, a change in how we do fault detection, isolation, response, or FITR. That would allow us to recognize this kind of event, and the software would automatically do it. So those are trades that we would do relative to what that means across the board in terms of software implementation versus having either the ground or the crew continue to execute the response for this event.
Thank you. Our next question is from Eric Berger with Ars Technica.
Hi, thanks very much for doing this. A couple of questions. First of all, for Howard, it sounds, not to belabor on the heat shield, but it sounds like there was plenty of margin, and I'm just wondering, what the best way for us would be to characterize this. It sounds like it was different from you expected, but maybe not necessarily that big of a concern heading into Artemis II. And then for Jim, I'm just wondering, how closely you're watching the Starship launch preparations down in South Texas. It's not an Artemis II thing, obviously, but it's pretty critical for Artemis III. So any thoughts you have on that and what's happening there would be great. Thanks.
Yeah, Eric, thanks for the question. We're always concerned when our models and our test program we think is very exhaustive and only test so much on the ground, and of course the models has limitations. And when we have unexpected behavior, we're going to drive to find root cause. We do have a significant margin on the heat shield. Of course, it protects against uncertainty in the trajectory, uncertainty with the aerodynamic environment, aero heating environment that you normally see. So we try to protect against that from the models. And so in this case, we're going to be very exhaustive in our assessment of what we found and what we experienced on Artemis I. And so I think we're being very cautious. I would say I'm being very cautious, let's say it that way, as a program, to make sure we're doing our due diligence. Jim mentioned that earlier. Vigilance is very important for us as we fly crew going forward. And so you'll hear about the amount of effort we're going to put into to make sure that we have the best heat shield possible to fly humans going forward. And, the data will inform us, like I said. And of course, we protect for a lot of different kinds of variations that could happen during reentry. And we want to make sure that we have significant margin to protect against the various types of uncertainties and variations that you might experience when we re-enter the atmosphere.
Yeah, thanks, Eric. Absolutely watching the Starship launches. We need them to launch. We need them to buy down technical risk for us around cryogenic propellant transfer. They obviously need to launch a few missions to make that happen. That doesn't mean all progress has stopped for us. We continue to have contract milestones with them to buy down our risk, to show progress around a multitude of things, including tech development. So yeah, watching it, looking at the contract that we have with them, and frankly the technical risk they need to buy down before we're ready to launch crew. So absolutely watching it.
Thank you. Our next question is from Irene Klotz of Aviation Week.
Thanks very much. For Howard, after the exploration flight test 1 in 2014, there was some redesign of the heat shield. I believe some of the Abacore was taken off. Is that at all going to be looked at when you're looking at the charring that you saw on this that wasn't expected?
Yeah. Hey, Irene, I'll maybe you know this already, but I'll clarify. We had a monolithic heat shield on EFT1. That means the heat shield was one piece. We went to a block design, 186 blocks, to allow us to not only save mass, but also from a manufacturing perspective, and give us, I would say, less trouble from a manufacturing perspective as well, in terms of consistency and timeliness. And so certainly we're going to look at the data from EFT1. We're going to look at the response on the heat shield from EFT1. We had a lot of sensors from EFT1, and we'll correlate that data as well as the data we got from Artemis I. So both that data set will be very valuable. However, that was a monolithic heat shield, and we have a little bit of different architecture for Artemis I. But certainly from a performance perspective for the material, it'll be very worthwhile to investigate.
Thank you. Our next question is from Stephen Clark of Spaceflight Now.
Thanks. I think my question's maybe for all of you, actually, but if you could walk through some of the upcoming milestones from the hardware perspective that we can see with progress toward Artemis II, like when that engine section mate is scheduled, when the core stage will be shipped to KSC, when the boosters will get to KSC, the crew module, service module mate, things like that. Walk us through what milestones to look for the rest of the year into 2024 in as much detail as you can. Thanks.
Yeah, Jim, I'll go ahead and cover the SLS piece. So for Artemis II, Stephen, just starting kind of at the bottom of the rocket. I mentioned we've got to do that join of the engine section, install the engines. For the core stage, we're looking at a ship date for the core stage in the June-July timeframe to KSC. That's well in advance of their need date. And then for the boosters, we've got the booster segments in storage. We'll be able to ship those when KSC needs them. We'll have them there in time for that. For the forward and aft skirts on the boosters, we've got those in place at KSC. We'll start doing the testing on those in time to support integration with EGS, and we've got ICPS in storage at ULA's integration facility for Artemis II, and then our structural adapters in the OSA and LBSA are ready to go.
Thanks. We'll go to Howard next.
Sure. I think I mentioned this earlier, but I'll give you some dates. Let's see. For SM, where we think the SM will be complete, will be mid-May. I talked about the testing for the acoustics, and of course, we'll do the final wrap-up with the SM in terms of getting ready for the mating. For the CM part, we'll be in the mid-June timeframe, and we'll start mating probably by late June, this summer, that is. And that's the major milestones ahead for the program.
Thanks. And Sean.
Okay, so let's see. Well, we'll start our multi-element verification and validation at the pad this summer. The mobile launcher is projected to be ready to start Artemis II processing in December of this year. Stacking ops will occur early in the first quarter of 2024, and then our integrated operations will start around June or July of next summer, leading to the targeted launch date in November of 2024.
Thank you. Our next question is from Alicia Sowers of Mashable.
Hi, this is for Jim. The latest ASAP report brought up some concerns about the safety culture as it relates to manual command error during the second launch attempt. And the panel had suggested that the way that issue was communicated was not up to the standards of NASA's organizational silence training. So I'm hoping you can respond to that finding, explain sort of what the breakdown in communication was and how you guys are addressing that. Thanks.
Yeah, thanks, Alicia. You know that I know that the EGS team and the SLS team have talked with ASAP about it. I've talked with ASAP about it. I think what we found there was actually I think we'll continue to implement changes, but we implemented changes immediately thereafter, like making sure Charlie made sure, hey, we have enough time for our teams to get the updated procedures. We were changing procedures as we learned how to load the vehicle. We took a step back and said, let's make sure we have some time to look through the procedures with John and his team. Let's make sure we have time to practice the procedures, that they're implemented the right way, where we went from manual to automated, where we could automate things, and we took time to test those procedures. So, you know, I think those were implemented and used effectively by the EGS team to load the vehicle in a later test, in the tanking test, and then in the run up to launch. Those themes will continue as we do future launch attempts. So again, that's part of the lessons learned process that Sean and his team are bringing in. So from my perspective, those were addressed. I won't say they're behind us because we always have humans in the system. But as someone said, right, we're going to make mistakes. Let's just not make the same mistakes. So I think we've implemented the right way to take care of what happened there, and have addressed it with ASAP.
Thank you. Our next question is from Christopher Mick of the Hudson Star.
Thank you. Yes, I had a question kind of broken into two parts. I believe it'd be for Sean and Howard. Looking ahead to Artemis II, I was wondering if we could expect any differences in the kind of rollouts, wet dress rehearsal, any procedures that might change from what we saw with Artemis I. And then the part for Howard was, I know Artemis I was obviously a very censored up mission. I'm wondering if Artemis II is going to be comparable to that, with the first time with crew being on board and testing those new systems being added, if it'll be comparable or kind of different.
Yeah, this is Sean Quinn. As far as changes planned for Artemis II, we're planning on doing a tanking test. We do not plan on going through a series of wet dress rehearsals that we did for Artemis I. We are applying a number of lessons learned to our launch countdown procedures and making changes to some of our software, automating things where we can, and that's pretty much it for significant changes for the Artemis II launch.
Yeah, this is Howard, and we would have comparable set of sensors on board Artemis II. Of course, we won't have the Munikin and the sensors and the amount of sensors on the Mare payloads inside the cabin. But from a spacecraft perspective, we would have comparable set of sensors to gather the data we need from Artemis II.
Thank you. Our next question is from Kiana Smith of Inverse.
I think this has already been addressed, but just to confirm, did anything coming out of the data that you've seen so far on Artemis I, that's not shifting the Artemis II launch date one way or another? That's still set, and yeah, I'm assuming you're not expecting that to change?
Yeah, Kian, I wouldn't expect it to change. We're pressing ahead with putting the vehicles together, building them up as we had planned while we're looking at the data from Artemis I. But that hasn't changed our planned launch date. You know, if we come in and say, hey, we need to do a series of tests before we go to this next milestone, then we'd address it that way. But right now, there's nothing holding us up based on what we learned on Artemis I.
Thank you. Our next question is from Lucy Arborg of AFP.
Hi, thanks for doing this. Question for Jim. If Artemis II is planned for November 2024, what can you tell us regarding the timeline for the Artemis III launch? Thanks.
Yeah, thanks, Lucy. We have always planned for roughly about 12 months between those missions. That's still what we're planning to. We've always characterized it as, you know, that is another mission that adds to the complexity, both in the mission we're flying and the hardware that has to be developed for that. Eric Berger asked me before about Starship. Obviously, we need a lander. Before that, we need to complete an uncrewed lander before we would do that mission. So that those two milestones are ahead of us, in addition to the tech development that has to occur for Starship. And then we have to have our suits developed for the exploration on the surface. And we're down a path with our contractor for those surface suits. That's Axiom. They've stepped off and have hit for development some of the certification reviews that they've had, but obviously we have a ways to go for that. So our plan has always been 12 months, but there are significant developments that have to occur, and that's just the nature of trying to land people on the moon. So we're still sticking with that 12 months, but we're always looking at the development of all the hardware that has to come together for that.
Thank you. Our next question is from David Curley with the Discovery Channel.
Thank you. Howard, sorry, back to the heat shield again. If I understand you correctly, I mean, it's an ablative shield, so the material is supposed to burn off. It was charring and breaking off. Can you characterize the behavior of your models versus what you saw and why you're concerned? And also the joints. Did you see anything in the joints in the heat shield? I know that was a concern.
Yeah, I'll answer the last one first. No, the joints responded as we expected, so no issues on the joints. I would say that when you say models, I guess, you know, the models are best as we can do on the ground. It's like ground testing. On ground testing, we did see the charring, and then we did not see some of the phenomenon relative to the charring liberation that came from some of the blocks. And so that's where we're scratching our heads a little bit relative to, hey, how did our models or test program not pick this up? And so we're evaluating that as well along with the data. So that's where we stand today, and I think we got more work, like I said, to go and try to figure out this phenomenon and understand going forward if there's anything different we need to do.
Thank you. Our next question is from Gerald White with GW Studios.
Yes, hello, thank you. There were 3 coronal mass ejections during the Artemis I mission, one on November 22nd, another one on December 7th, and a third on December 9th. Such major proton events can pose a serious threat to the astronaut safety, might even kill them. How well did the Artemis I shielding hold up against these solar flares, and what were the radiation detector readouts regarding proton flux and energy? Thank you.
Yeah, I'm not as familiar with you as those events. I talked a little about those radiation sensors. that we had across the spacecraft. So we do have radiation protection within the spacecraft. Of course, we're measuring the radiation we experienced on Artemis I. That data will be very important to inform us going forward.
Thank you. Our next question is from Robert Perlman of Collect Space.
Hi, for Howard, when do you anticipate all work on the Artemis I crew module to be complete? And you can set that vehicle aside, and do you have a target date for that? And just to clarify, is there still physical work being done on the spacecraft now, or is it all just analysis of the data already collected?
Yeah, from a spacecraft perspective, if you're not familiar, we're actually using the Artemis I crew module for another test called the environmental test article. The crew module for Artemis I will become what we call the ETA, or environmental test article. That test series of tests will basically drive towards the abort limits. So we're going to do, before we fly Artemis II, we'll run that Artemis I crew module through a series of abort vibration and acoustics levels that we would experience with the launch abort system. So the job of the Artemis I crew module is not complete. We have taken the heat shield off. We have removed the avionics that's needed for Artemis II. We are in the process of doing, actually, when I say we, the exploration ground systems, Sean's team is doing all the work for us, doing the decontamination and starting to, for example, pull the TPS backshell panels off and such. So we've been doing a lot of that work, and then we'll be getting the spacecraft back from Sean's team, and then we will reconfigure that for the ETA test that I described going forward. So there's more work for this Artemis I crew module. It did a great job of going to the moon and coming home, but that job is not complete, as it has another job to do to help inform us of our launch abort capabilities for Artemis II and beyond.
Thank you. Our next question is from Jim Siegel of NASA Tech.
Hi, and thanks for taking my question. I have a question about funding. I was curious as to how much of the Artemis II mission is fully funded, and how much of the future missions, Artemis III and so on, beyond that, are also funded. Thank you.
Jim, thanks for the question. The Artemis II and III missions are fully funded on the schedules that we have today. Our budget, the President's budget that's coming out soon, starts to look at the funding for our out-year missions. When we look at 4 and 5, those missions, we're building hardware today for 4 and 5, and starting to order stuff for 6. So obviously those are funded, but the President's budget run out that's coming out here includes funding for those out-year missions. We anticipate those to be fully funded, and of course we always work to support the President's budget, which balances a lot of priorities across the whole government.
Thank you. I think we might have time for one more question. We have Ken Kramer with Space Up Close.
Thank you. Thank you for doing this, and good luck to everybody. My question is for John Honeycutt, I think. Can you give us an update on the production of the new RS-25s and the exploration upper stage? When will the units actually be available, and what mission you're going to use them on first? Thanks.
Yeah, Ken, thanks. The exploration upper stage will be the upper stage for Artemis IV. So right now it looks like we'll get through that development and be ready to support the agency needs for Artemis IV and subsequent missions. And then on the RS-25 area, we ended the shuttle program. The SLS program had assets from the program of record in 16 RS-25 engines that were repurposed for SLS. Obviously we had the need to start the production line up again. So we did what was called a production restart activity, and we have begun a series of, I believe it's 11 or 12 acceptance tests. We've done 2 of those, and as I mentioned in my opening remarks, we'll be doing the 3rd acceptance test this week. And so, you know, our affordability initiatives on RS-25 have worked out really well, and I don't see any issues with the team getting through the acceptance program the way we have it laid out today.